Hi, my name is Chu. Welcome back to my tutorial, Time Series Analysis using Python. As I mentioned it before, I use this book as my guidance for my tutorial, Time Series Analysis, Univariate and Multivariate Method by Dr. William W.S. Wei. Today, we are going to learn some fundamental concepts of stochastic process. And we also learn some of the statistic function of the process. Mean, variance, covariance, correlation functions. We will take a look at a special case, strictly stationary process. We also clear some of the concepts for the first order and second order stationary distributions. Then we compare strictly stationary process and covariant stationary process. At last, I will show you how to do simulation regarding to different distributions in Python. And I hope my examples will help you understand these concepts. Let's start. First, we take a look at the stochastic process definition. It is a family of a time index random variable ZWT. And this ZWT sequence is regarding to the time in order and W belonging to a simple space. Consider a finite set of a random variable ZT1 to ZTn. From such stochastic process, from the time backward and forward, the n-dimensional distribution function is defined as below, with the variable xi. Let's take a look at the following simple example to get a better understand this concept. In this case, ZWT is twice of the value of the true dice shown, and the true dice has 6 number in each space. So W is belonging to this space. Suppose you roll your dice 3 times independently. You may get a particular sequence like 1, 3, 2. From distribution function f zt regarding to xn, you may have 2, 4, 6. Now, let's take a look at these statistic functions of the process. You may recognize them as replace xt with zt. Friends, for the covariance function and the correlation function between zt1 and zt2, and here the zt1 and zt2 are regarding to two distribution functions at a time frame with equal size sample space. Next, let's take a look of a special case, strictly stationary process. This process, mean and variance are constant. Take a look of the covariant functions and the correlation function between zt1 and zt2. They're the same in the k time interval. Comparing the time t now to backward and forward, their functions are same. Just think about the example rolling dice before. As you roll your dice 3 times independently, the sequence has the same IID variables. For this type of the process, consisting of a sequence of IID causing random variables, the process is clearly strictly stationary. because in any order of the sequence, there is no joy moment exist. In the real world, such kind of time series process duty does not exist or no interest in our study. In a finite set of time series data, we look at the definition for the first order stationary and the second order stationary. For first order stationary, if its one-dimensional distribution function is time invariant. We have learned from the last example before. For the second order stationary, if its two-dimensional distribution functions are time invariant. So you extend this concept to the nth order stationary distribution. In the real world, other than the simple IID case, it's very difficult or impossible actually to verify a time series sequence distribution. Thus, we often use a weaker sense of stationarity in terms of a moment of the process. Don't worry, if you still don't see it now, you will see it in next two examples. Here, there are two examples. The first example is a strictly stationary process, which we have talked about it. In our program, we are going to generate 100 discrete data with a space 1 to 6. In example 2, it is covariance stationary process, and ZT has a function A times sin with the W times T plus theta. A is a random variable with a zero mean and a unit variance. Theta is a random variable with a uniform distribution on the interval -pi to pi, which is independent of A. What is W? Think of sine's recursive functions. You get the value equal to 0 and will wait until you come back to the 0. This is the period. Let's say it's 8. Then we had a function 2 pi divide W. For this function, we can calculate it. W equal to pi over 4, which has 45 degrees. Let's set A has a variance as 4, then sigma equal to 2. Let us start to practice coding in Python in the following steps. Let's load some Python library. For NumPy, it is a fundamental package for scientific computing. I give it a short name as NP. And then we import map library. Since we're going to use map library to help us to calculate pi and sine. And then we import numpy.random as ren. This will going to help us to generate the random seeds. And next, we import pandas as PD. We're going to create a data frame to storage all the data we need. In our first example, y equal to 2x. The goal is to generate 100 numbers xn as you roll your dice 100 times independently. And your distribution y will be equal to 2 times x. First, we create an empty panda data frame. Inside it, a variable named as df. Then I create two empty lists for x and y. Next, the for loop for I in range 100. This for loop going to run 100 times, and each time it go to the function ram.ranIn, which is generate a random integer with a minimum bound 1 and a maximum bound at 6. For each of the value it generates, I use .append method to append into X list, and I append C times 2 and into Y list. After the for loop, you have the 100 value in X list and Y list, and I assign it to the data. Let's run this. Now we're going to check what we have in our data frame. So when you run your function, you may just click this button. You can run it for the puzzle code. If you run the whole program, you click this button. So I select the df. Well, I want to see what data storage in df. See? Here, the shape of the data frame. It's 100 row times 2 columns. Panda already create a simple function for you to calculate some of the statistics like mean, variance, covariance, and correlation. We simply use df.y and .mean parentheses, which looking for the mean value of the y sequence. Let's run it. I select this puzzle code and plot this button. Now we can see the mean is 6.04 and the variance is 7.92. You may have a covariance functions regarding for the x and y. The first 1.979 is regarding to the x variance relating for itself. 7.9175 is the variance regarding to y itself. 3.96 is to covariance regarding to x and y. You can see why this is called strictly stationary process. You see the x and y has a perfect correlation. In the real world, such kind of time series doesn't exist. But we get the sense by looking up the sequence. Now I use df.plot. These we're going to plot the sequence of x and y. And we use plot.show to show the pictures. This is example 2. We had a function a times sine with pi over 4 times t plus theta. Our goal is to generate 100 numbers, random number for theta between negative pi to pi. As I mentioned before, the random generator generated pi at a flow numbers around 3.14. Also, we need to generate 100 random number for A, which following IID distribution with mean 0 and sigma equal to 2. Then we generate time t in order from 0 to 99. So now we create an empty Panda data frame and give it a name df. Then we start to generate random number for theta and a. Theta is for the uniform distribution, so I use ran.uniform to generate the flow number from negative time pi to pi, and assign this sequence to the data frame and give it the common name theta. Next, we use the ran.normal to generate 100 random flow number with a mean 0 and sigma 2, and storage to the data frame with the column name A. Next, I create the time with the order from 0 to 99 and assign it to the data frame as the index of the data frame. Next, I use Python lambda function. Lambda function is good for calculate complex function. First, I create 3 variables with uppercase A, uppercase T, and theta. The following function is exactly same as the function we have seen before. But one thing I had mentioned before, since theta is the sequence of the flow number, we need to use a mat.degree to convert this value to the degree. So we have the 45 degree times t plus another random degree. And here, regarding to the order of the variable we created before, we assign the value with the data frame dot a, time respected to the index, and theta respected to the theta. And then the math function in Panda, we do the parallel calculations for each row. Then we have 100 value. It comes up at the end. Storage to the list and y. And now we assign this value to and storage to the data frame and give it the name y. Let's run this. Take a look at the data frame, see what we have. So we had 100 rows and 3 columns in our data frame. Perfect. Now, we use the same method to see the sequence mean and variance, and we try to discover what is the covariance between A and Y, and the covariance between theta and Y, and discover the correlations among these variables. Let's run this code. We have the mean for the sequence Y is negative 0.2649989. We had the variance for sequence Y is 1.4818. For the covariance A and Y, we have a negative 0.31188. And the covariance for theta and Y, we have negative 0.0346. And you look for the correlationship among these variables, you will see it's very, very low. That's why what we say, the second order with two-dimensional distribution functions, you had much weakened stationary. And let's plug the Y sequence and take a look how it look like. My friend, these are the two examples about the strictly stationary process and the covariant stationary process. I hope these two examples you will get some sense how they look like. I already upload my code in my GitHub. You might follow this link and go to try this Python code by yourself and play around. As you play more, you'll get more sense, understand these type of stationary distribution process. Thanks for your time for watching. I hope to see you in next video. If you feel this video will help you understanding the stationary distribution process, I'm very happy to hear that. And you may subscribe it below. Thank you so much.